Hello, this is Anthony with Copley Controls. We have this ROS2 example. It's writing a simple publisher subscriber in C++. I just followed it step by step. It takes about 20 minutes. Um, when you are finished with this example, you'll have a ROS publisher node. It's just publishing this string, and then you have a subscriber node that has subscribed to that topic. So you can read up about topics and how to publish and subscribe to them. Um, but what I'm going to do is just simply make some edits so that we can use CML and actually use this example to make the moves to these positions. So we can maybe interpret these strings as positions and make some simple point-to-point moves using our Copley motion control library. So all the code that I edited is right here. We're just going to do the amp class do move from point to point. So um, this is what you get with the example, the publisher.cpp. It creates a topic of type string, and then I edited it so that it just prints out just publishes the number. And that's it. And then the subscriber node, I put the references to the Copley Motion library here in the subscriber because the subscriber is the node that'll be making the moves. So we're going to use a CAN network to send these commands. So this is the subscriber. This is just the standard node that you get with the example. So what I did is, this callback is called every time you get an update on the topic. And I interpret it as a commanded position and just make a move to that position. So we should be making trap moves, trapezoidal moves every time we get a new number published to the topic. So here I just open up a CAN node. I have, right now I have the Copley Nano, the NPS. I can do 35 amps continuous and 70 peak. Tiny little drive, tiny but mighty. So I've got a CAN node ID of 1. Right now I'm connected to it over serial as well to our Copley software CME. So I can actually monitor using the oscilloscope here and make some traces. So I'll just begin recording that now. And so all I'll do is just open up the network, initialize the amplifier object, and then it'll spin up this thread here, this subscriber thread, and that thread will be making this callback to receive that new commanded position from the publisher and then make the move to that position. So first I'll start up the subscriber. Okay, the listener. Then I'll open up another terminal here, and I'll start up the publisher. Okay, we can see the publishers sending new commands over ROS, and then the subscriber is actually making the moves to the servo drive here. So we can see these trap moves in this kind of step pattern. And yeah, this is just a very simple example of how to integrate our software, the Copy Motion library, with the boilerplate standard ROS examples that are on their website. So please reach out with any questions. Visit our GitHub page. All the code here is available on the Copy Controls official GitHub page. So thank you, and see you next time.